Welcome to the Data Future channel. This is Shekhar and I am a data scientist. So in this tutorial we are going to see the time series forecasting using Arima model for electricity production. So let us start with this um, project. So I'll be discussing about the electricity production, how we can build a Arima model so that we can predict the future electricity production for next few years. Okay. So before starting with this, we need to import some of the required libraries so that we can carry out some data manipulation. We can build the model. So the first thing is you have to import the libraries. Okay. Now second thing is you have to load the data. Now I am having this data by using a pd.read_csv. I am reading the CSV file, which is electricity production time series. Okay. Now there are two columns. One is date and electricity production. Okay. Now this date column is the time column. Okay, so because of this we can see that it's time series. Now you can see here this is the monthly data actually from 1985. So if you do the last sorry, if you do df dot tail the last five rows, you can see up to 2018 this data is there. So and what are the different how many records are there? So 397 almost these values are there. So 397 rows are there and two columns, date and the electricity. But here is the date is our time date time column actually. So we are this is in a string, so we have to convert into a proper format. So pd.to date time, so it will convert this into a proper date time format. So if you can see here df.head, you can see now the dates are formatted correctly. Okay, yes, here. Now what we have to do now, this is the column, but we have to make it as an index because this is the very useful column, these values. Okay, so simply we can do this by setting an index to that particular column, and then if you can check, now these becomes an index and these are the values. Okay, we will check whether there is any null values, null records. There is no null records. This is showing this. So if there is a null records, then that null records can be, or the missing values can be filled by the backward fill. Okay, but here there is no case of backward fills because there is no null values. The first thing we have to visualize the data. So df.plot, and if you give the size, you can plot this, visualize this data. You can see here is the data, and here you can see here you can see this data of electricity production for these number of points from 1985 to 2017 almost. Okay, the next thing is yes, data is there. Now what we have to check, so we have to check for Arima model. So Arima model is basically autoregressive integrated moving average. So whenever we say so first AR is autoregressive, I means integrated, and MA means moving average. So in that these three parameters which take care of this Arima model. So the main objective of this Arima model is to find out the optimal value of PDQ. Okay, so what exactly PDQ is? So P is refers to the AR model, order of AR model. D is the difference, that is the integrated, and Q is the order of MA. Okay, So AR is considering the how much lags we have to consider for the autoregression. Then I is integrated means what we have to do the time stage stationary, and MA means we have to consider the errors actually, errors, regression errors basically. So yes, so we will use the grid search and um, find the optimal parameters of these things, the PDQ, and there are seasonal parameters are PDQ also. Okay. So for each combination of these parameters, we will create this model with Sarimax. Sarimax is the function which is used for seasonal Arima actually, and function for stats model, which and it accesses its overall quality. Once we finalize the parameters, these parameters are based on the models which can give the lowest value of AIC. So here what we have done, so we are considering parameters like 0 and 1 for PDQ. Okay, and here what we are doing, basically using a list of the product of PDQ. So it will create, you can see here. So if I run this, okay, you can see it is creating the PDQ. So PDQ means it will create the these combinations. So the orders, the PDQ, okay, and seasonal PDQ is also there. So which can consider the seasonality also. Okay, you can see here this one. Yes. Okay. Yes. So we have created these two list of tuples, and we are creating this thing, these approaches. Okay. Now, basically what we are doing, so we are creating this combination and checking which model will works fine. Okay. So so for that we are considering the AIC, Ekek information criterion, uh, which model is having the lesser AIC value that we are going to select. Yes. So here is the we are creating. So we are considering the parameter in the PDQ. So PDQ is here. Okay, it is a list of these combinations, and we are running one more for loop is the seasonal PDQ. So this one means we are combining these. So we are running for first combination with this all the combination. Okay, and then we are creating a model. So I'll say it's a model. Okay, this model this model we are importing from the stats model. Okay, sm.tsa.statespace, and we are importing a Sarimax. Here we are providing data. Order is the param, and seasonal param, that is seasonal PDK. Here we are info stationarity is false, info invertibility is false. Okay, now here we are fitting the model. Okay, and then check for AIC score. Okay, so when you run this, you can see you will get these combinations, and in front of this you will see this AIC score. Now this model, here we have to select the best combination which is having the lowest value of AIC. Now till here we are having a 1879, 1836, oh 1773 is there. Still it It's 1773. Okay, yes, still it's running. Checking all combinations basically. Oh, great. It's 1725 is also there. So here the lowest value of here is the 1725. So here which is the combination? So 1 1 1 1 0 1 1 1. Okay, so here I am putting this value. So we are creating the Arima model. Okay, the best model I'll say. It's a best model I am building with this optimal parameters. Now here is the 27 is this one. 1 1 1 0 1 1 1 2 12. Okay, so here is the best one, and when you run this you will get the result summary. So here is the result summary. What it tells, it's a results from output of Ceremax return the significant amount of information, but we will focus on the table of coefficient. Okay, this one. The coefficient column shows the weight of each feature, how each one impact the time series. The p-value is greater than z. Column informs us the significance of each weight. Here the each weight has p-value lower than 0.07. Okay, here so that it is reasonably to retain all them in our model. Okay, so we can use everything in our model actually. Yes, so this is the one. So second thing is we will check the model diagnostic. So here you can see these residuals are the accumulated near the mean. This red line is following this yellow line in this histogram. Yes, this in QQ plot, these data points are following the red line, and here also you will see there is what we can say. Mm, yes, the residuals over time don't display any obvious seasonality here. Okay, and appears to be white noise. Okay, this is the confirmed by the autocorrelation plot on the bottom right, which shows that the time series residuals have low correlation with lagged version of itself. Okay, so there is less correlation. So in the top right means here in this graph, actually here in this graph, the red KDA line follows closely to N01 line, where is the standard notion of normal distribution with mean is 0. Okay, and standard deviation is 1. This is the good this is good indicates that residuals are normally distributed here. Okay, and the QQ plot on the bottom left side is order distribution of residuals. The blue plot follows the linear trend. Okay, where again this is the normal distribution, standard normal distribution. So the residuals are normally distributed actually. Okay, so we have to validate the forecast. So how to validate the forecast? So we have to um, predict actually, um, and once and we have to decide the confidence interval also. Okay, so here if you can check for this, so we are considering this as a confidence interval. So lower limit and upper limit we are putting. And here whenever we get this results, so model dot fit means we are fitting it uh, to all the data actually. Okay, so whole df we are fitting the model. Now here we have to predict, and we are predicting it from 2017 onwards. Okay, and this is the confidence interval, and whatever the predicted values, okay, predicted values, we are taking a predicted mean dot predicted mean, so you will get the forecasted values. Okay, so here if you check, so these are the actual values and these are the predicted values for these dates. Okay, means we have predicted for 2017 to the last value. Okay, now you can plot it here, these actual values and the predicted values with confidence interval. So you will see these results, means the actual values and the predicted values are following each other. Okay, so there is no difference. So you can check what is the error actually. It's a mean squared error, means we can subtract, make the subtractions. You can square these, add this, and divide it by this number of points. So here you will get that value, that is the MSE, that is the mean squared error. So mean squared error is very less actually, it's 20 actually, and when you take the root of this, you will get the 4.5. So our model is working fine here. Now what we have to do, uh, uh, okay, yes, so here what we'll do, so this we are plotting it as the dynamic. So uh, earlier we have not selected this as the dynamic one, but because here we have considered the dynamic is false actually. Okay, so we are considered only the date time. We are considering from 19 here. Let me check. Okay, and it will consider this dynamic plot, but you need not worry about this particular dynamic plot actually. So let us move to the next point where yes, here's the dynamic um, value we can predict here. So we have considered the data up to a 1998, and later on we are predicting it. Okay, so for here we have considered the dynamic is false. Here you can do the dynamic is true, and you can plot that. Okay. Next thing is we have to predict the future actually. So what will be the our future values? Okay. Now future predictions will be from 2018 second month we are predicting up to 2019. Okay, means almost we are checking for next 12 steps here. Okay, and you will get that values, and we will visualize these results in our whole chart actually. So you can we have started from 1985 and we predicted till 2019 actually. So up to here we are getting a actual one, and from here we'll get the predicted value. So these are the predicted the electricity production for next few months, and yes, for next 12 months actually. So based on that, you can plan according to what are the resources required to produce the electricity mostly. Okay, so this is all about the Arima model, the time series forecasting on electricity production using Arima model. Okay, um, that's all from my side. Thank you.